Here I present you Mark Orlando and will show this project and he will explain further what is this about. So,
So, when working in the hospital as a therapy aide, I realized that there was an issue of pressure ulcers in our patients. And so, a lot of times we would have to manually flip the patient over and stuff pillows underneath them to offload their hips. This is done in the hospital because when you're sitting on one side of the when you sit too long without moving,
and we all five of us have been together for 2 years now, and so we were kind of just
blood is not allowed to
ideas
refill.
as like we were getting
Pressure on parts of the bones, just like your hips and sacrum. So this device is supposed to reduce the load on nurses by automatically flipping turning patients. So maybe set this 3 degrees. Anymore would be a lot of pressure. And it's every 2 to 3 hours. Or if it's severe,
for like hospice centers, if you have like an elderly person at home that you're taking care of.
So on this device, just make sure these valves are closed. Here, the clinician can adjust through this dial the rate at which the patient's turned at. It's in minutes. And then there's a little user interface. So they press these buttons to do the desired pressure of the air cells that are here. And so we really wanted to have 30 degrees of pressure. And so the motor turned on and this plate. And you can see here it's going to 30 degrees. So what's really nice about this is so pressure sores are considered a never event in the hospital. So if you do get pressure sores in the hospital, Medicare and Medicaid won't reimburse you. So this is what the big selling point for our device would be, is like all these hospitals in the United States, every single patient is susceptible to pressure sores. It only takes 3 to 5 days to develop them. And so our biggest market buyer should be hospitals or skilled nursing facilities where you have even like less of a nurse or even higher patient to nurse ratio. So it demands on to for each patient every 2 hours to turn them. It's a little hard, especially if it's just on one nurse. It's really a 2-person job to turn somebody and stuff that goes underneath them. But yeah, in this model over here, we designed in consciously. This is our first prototype, and we were able to incorporate this water sensor. So this water sensor goes off when there's moisture around. So if the patient wets themselves, there's an alarm that goes off, and that allows the nurse to know you have to clean up your patient, because if you have urine or feces, you're a higher risk of getting an infection from those open sores. Any minute now it'll go off. It's off right now. It's on. No. It's hard to hear because of that high frequency. Yeah, and so here's a schematic of the electronics. And there's a animation of like what it should be working out in the hospital. Since our device is separate from the mattress itself, it can even work on the sofa or a wheelchair. That's what's really lacking in the existing products in the markets. And this one costs us around like $200 to manufacture. The specialized ICU beds that have similar function are tens of thousands of dollars.
So basically inventing a device.
So what are your thoughts?
So this is going to be used at the hospital or anywhere, or just a hospital?
Our biggest market would be the hospital in America. This could be sold to individuals for, let's say,
Okay.
a bedridden parent or grandparent at home.
So this is the first time that got invented.
There are similar products on the market.
Similar.
but nothing really has this feature of being separate from the mattress itself. So we could put this on any bed or any recliner chair, wheelchair. It's right because it's good for your mental health as a patient to be moving. It's
I think that is one of the biggest things.
rather than stuck in a hospital or hospital bed.
He says right now.
And
So-
then this will still allow them to stay there for a long period of time without getting
Without having difficulty to move around, because they always lay down.
Yeah, so
What is benefiting them for the patient?
the design allows them to be sitting up. Or if their bed allows them to step forward, they'll still get the same effect and still avoid getting pressure sores and weakness in their bed.
So that's going to be hospital use and office medical use for the patient,
Mainly in the hospital.
mainly for the hospital.
Yeah. Ideally, you want to transition from being bedridden to back into daily living function of walking, moving around. What?
What part of the body does the source typically occur?
Here, for the most part.
That is the most part to get
Here
sore,
and here.
and that this one is to prevent having it sore for long time period that the patient is laying down in bed.
And the next common place is in your heels. So,
Where?
the heels, the back of the heel.
Why?
Why? Because this is a high pressure area. When you're laying flat on the bed, you get a lot of. Uncle Jack has gotten a sore on his heel when he went to the hospital.
I know they do. They make you sign all these
That's
My cousin Jack?
exactly what happened. Is from the pressure.
some deathly disease while I'm in here and die. You can't sue me, neither can your family.
So yeah, this is pretty cool. We learned to use the laser cutter to build this, and this box was cut in a laser cutter. And then here's the circuitry, a lot of prototype board, and learn how to solder. Learned it all this semester, the circuits, how to wire everything. So the real heart of the machine is this chip over here. It's an Arduino. It's a microcontroller. So instead of like a microcomputer, its mainly function is to handle controlling devices. It's actually a pretty rudimentary chip, but we were able to make it work.
This would make Grandpa proud.
Maybe. I think it confuses him.
So by
There's a mechanical.
so how long that this has been tested before you guys put them together?
We only got preliminary testing. We kind of ran out of time to do the test that I want to do to this device, but it's just time constraint, and that was really it. Time constraint and budget constraint. It's, everything costs money, and it's like stuff breaks on you. Pivot design. Originally, we had a simple design for this. This is an escape valve that's controllable. Originally, if you see over here, it's just a solenoid. So a solenoid is an electromagnet that pulls the shaft either one way or another. And that's a simple program or a simple binary switch to get it open. But that didn't really work well. So when we scaled up, it didn't work well. We had a bigger solenoid, so we had to switch to motors.
That'll be the main mechanism.
And the machine makes this one tilted for them to turn. This one.
That's the main thing.
And could you explain this in the chart? This one here. All of them. Is this part of this one?
It's all the same.
They are the same.
This figure is just showing you there's the cyclical action of the device, and here's just a bell curve of it hitting that angle of 30 degrees. This says 29 degrees.
All right. So the one over there is this one here, the one that you guys invented.
Yeah, and then
This one, this are here
this is a 3D rendering of
from the machine.
the pressure areas found in the machine when it's inflated.
And then the result is this one here. The figure 9 stage of the fabrication process.
Yeah, that's just how we were building it.
I see. Okay, got it.
So have you applied for a patent for this?
Not yet. Patent costs about $10,000.
Planning to do a provisional patent, which is only about 100, and that gives us like a year to file an actual patent. So if we decide to do it, at least we have one.
So you guys are all graduating this May 4th?
Yeah.
And then after graduating on May 4th, what is the next mission or
For me, it's medical school.
medical school? Awesome. And what is you're gonna be majoring at?
Majoring? You don't really major in it. What do you mean? Like, what do I want to
Oh,
specialize
like
in?
specializing.
I'm
Sorry,
thinking about like cardiology.
cardiology. And how about you? What is your gonna be specialized in from
I think I want to
biomedical?
do general surgery.
General surgery, like specifically for children or
No adults.
adults? Okay, wow, that's pretty awesome. You guys doing a great job.
Jacob is as well.
All right, so you also in the biomedical engineering, and what did you specialize into?
My specialist?
In med school, what do you want to do?
I want to be an orthopedic surgeon.
Oh wow, that's beautiful. That's nice also. So still going to study after this graduation?
Lot more school.
More 8 more years or 4 years?
Probably 9.
Oh wow! So keep on going. You know, get energy, energized.
broken bones,
Broken bones.
worn down cartilage. I'd like to do
All right.
sports medicine focus.
So surgery. Mark will be in specialized in surgery, and Brian, huh?
Cardio surgery.
Cardio surgery. These are gonna be the future doctors, Mark and Marinotti. Yeah. Also a future doctor. His name is
Jacob Martinez.
Jacob Martinez. Congratulations, you guys. And congratulations for your invention here. They are all biomedical students.
So I wanted to have familiarity with the product before I was using it, like clinically. But the more I've gone, like at this point, I'll do whatever. Orthopedic surgery is my big, like, non-people, but there's so much that's interesting.
All right, guys, thank you so much for presenting your project, and we are delighted to see all this information that you are giving to us. And thank you for being part of the ASU student and graduating this year. All right, see you later. That's all, folks. We are done today. We'll see you later. And that's my son over there.